Good afternoon. I actually really like this lesson. It's called Powers of I because it's a very simple lesson where every single one of your answers will be one of four things. You'll either get a 1 for an answer, you'll get a I for an answer, you'll get a -1 for an answer, or you might get a -I for an answer. But let's make sure we understand why that is. Let's first remember that I is considered to be the square root of -1, which implies that I is the number that times by itself gives you -1. It's not considered a real number. It cannot be found on the real number line. Now, the interesting thing is since I times itself is -1, if you continue to multiply by more i's, you're going to either be multiplying by -1 or 1 and a -1, or 1 and a -I, or -I and a 1. What I'm saying is, I'm not trying not to confuse you, but let's do it let's just watch this pattern. If I give you an I, from this point forward, when I ask you what's I equal, you could say it's the square root of -1, but let's just say it's I. I mean, that's the simplified way, the most simplified way to write it now is just I. If I give you I squared, now remember, I squared, two i's multiplied together, is going to be a -1. So that's equal to -1. If I give you I to the third power, well, now let's think. Let's follow this pattern. If I give you an I times an I times an I, because that's I to the third power, the two together is a -1, and then I'm multiplying by an I, and that's how you get the -I. So an I to the third power is -I. Well, now the question is, let's keep going. What's I to the fourth power? Well, again, if I have an I times an I times an I times an I, what I like to do is pair 2 up and pair 2 up, because remember, what's 2 i's multiplied together? It's a -1. So I have a -1 there and a -1 there, and what's a negative times a negative? It's positive, and 1 times 1 is 1. So I to the fourth is 1. Now, the pattern is going to repeat. In other words, I have this I, -1, -I, 1, and then I'm going to repeat and start with this I again. In other words, an I to the fifth power is going to be just plain old I. And think about why that is. Again, if I have 5 i's that I'm multiplying together, remember, if I pair up, now I like to pair up 4 of them, because remember, 4 i's put together is 2 -1s. So 4 i's multiplied together is 1, and what's 1 times I? Well, it's just going to be I, because 1 times anything is itself, right? So we want to group our i's in groups of 4, or think of them as groups of 4, with either a remainder of 1 I, or if I have I to the sixth power, I times I times I times I times I times I. Again, I group 4 together, which makes a +1, and then the 2 makes a -1, and so I get 1 times -1, or -1. So I have 2 remaining, and 2 I squared is -1, because the other group of 4 will just be 1. So that's going to be -1. If I have I to the seventh power, well, that's going to be an I to the fourth. So now I'm going to start using exponents, because I to the fourth we know is 1. Then I have an I to the third, because there's 3 more from the 7. And again, we look back up here. What's our I to the third? Well, it's a -I. So that's a -I, because the I to the fourth is 1. And then here, the I to the third, if you want to break it into an I squared and another I, remember, I squared is -1, and then there's the 1 I. So we have a 1, a -1, and an I, we get -I. Now, if I go up to I to the eighth, again, that's going to be an I to the fourth times another I to the fourth. The 2 4's add up to 8. An I to the fourth is 1. An I to the fourth is 1. 1 times 1 is 1. And so from this point forward, what I do is if I give you something like I to the 327th power, all I'm going to do is start grouping them in sets of 4. So what I'm going to do is I'm going to say how many I to the 4th powers are contained in 327 of them. Well, that's simple division. I do 327 divided by 4. Well, that's going to be 8, which is 32. Drop down to 7. That's going to be 1, which is 4. Drop down to 3. So in other words, I have 81 I to the 4th, and then I have a remainder of 3. This remainder, oh, sorry, you can't see that. Apologize, because 7 minus 4 is 3. And then I have a remainder of 3, so I have another I to the 3rd. So now remember, I to the 4th is 1. Well, what's 1 to the 81st power? It's still 1. But then I have an I to the 3rd, and all you got to do is remember I to the 3rd is a negative I. So this I to the 327th power is negative I. If I give you, I love to give ones like this, if I give you I to the 4,444,444,444th power, I know that's just 1. How did I know it's 1 so quickly? Because 4, that's divisible by 4. That's just a bunch of 4s. What I mean by 4s, that's a whole bunch of I to the 4th 4, which is 1. In fact, I can tell you exactly what it is. It's 1,111,111,111. But what's 1 raised to that power? Well, it's just 1. So it all comes down to how many I's are left over once you pull out all the groups of 4. Let's do one more. Let's do I to the, and I'm going to make this one fairly simple, 442. And I purposely did that because this is not divisible by 4. But it is almost divisible by 4. I mean, it has a remainder, not almost. I shouldn't say that. But it's I to the 4th. Take my 444, not 444, sorry, 442, divide by 4, which is 1, 4. I want you to make sure you can see this. That's 0. Bring down your 4. There's another 1. That's 4. Bring down your 0. Bring down the 2. 4 doesn't go into 2, so that's 0. So I have 110 I to the 4th, and I had a remainder of I squared. Well, what's I squared? I squared is negative 1. So another little thing I do that makes it a little easier is if the exponent is even, you'll either get a 1. If the exponent's even, you'll either get a 1 or a negative 1. If the exponent's odd, you'll either get a I, whoops, I keep writing where you can't see. If the exponent's odd, you'll either get an I or a negative I. So I know there's going to be an I, I've just got to make sure, decide if it's positive or negative. What I do is I take that 333, not the 333, sorry, I'm getting a little ahead of myself, the 33, divide by 4, that's going to be 8, which is going to be 32, which leaves a remainder of 1. So in other words, that I to the 33rd power is I to the 32nd power, or 4 to the 8th power, which all that's just 1 times 1 more I. Well, 1 more, that's a positive I. If I'd given you 300 and, or sorry, not 3, if I gave you I to the 35th power, then that would end up being an I to the 4th 8 times, with an I to the 3rd left over, and an I to the 3rd would be negative 1, or negative I. So again, negative exponents will always be 1 or negative 1. Positive exponents will always be I or negative I. If you have questions, do ask me in class.